All right, so comparing linear and exponential relationships. So task 1, we're given 2 venues are possible meeting places for a yearly convention. Each venue projects a different pattern for the expected attendance at the yearly convention for an 8-year period as shown. So we have venue 1, so we have the number of years, and then the attendance. So the first year we had 2,650 people. The second year we had 2,800 people. And then for the second venue, this is how many people attended that as well. So first thing that we want to do is graph each set of data, and then we're going to figure out what type of function each graph represents. So we're going to practice typing the table into Desmos to create a scattered plot of the data. So we're going to go to Insert Table, and then we're going to type in all of the values of that table. So I'm going to go ahead and do that really quick, put that into Desmos, and then we'll graph it on our paper. So I can zoom it out to see my data. So I'm going to change my options so that I can see my data nicely. All right, so that data creates a straight line. So we're going to go back onto our graph, and we're going to plot a straight line. So we start at about 1,100, which is right here. Then every year, it's going up like this. And now we're going to do the same thing for venue 2. We're going to type the data into Desmos, we're going to graph it, and then we're going to determine which type of function each one represents. All right, here's my data for the second venue. It looks like we start a little bit lower, and then our graph is a little bit more curved for this one. So I'm going to change my color. And my graph is a little bit more curved, like this. All right, so our black graph, venue 1, is a linear function because it's a straight line. And venue 2, the one in blue, that one is an exponential because it is curving upwards. So a straight line would be linear, which that's venue 1. Or sorry, venue 1 is the black graph, that's linear. And then venue 2 is the blue graph. So let me see if I can change this color really quick. So that's the blue graph. All right, if the patterns continue, will the projected attendance at venue 2 ever exceed venue 1 at the same year? So we're going to go back to the graph in Desmos, and what we're going to do is we're going to try to figure out if the blue line is ever going to go above the green one. So in Desmos, we can type in this equation that we've used before, where Desmos will actually create a line for us. So that will be for our linear, and then this will be for our exponential. And we'll keep these equations in our notes. Oh, so this needs to be y2 and x2. There we go. Okay, so the graph of the blue one does go above the graph of the green one. So that means after 10 years, the venues are going to have the same attendance. So for part 2, after 10 years, the venues will have the same attendance. Since that's where they intersect, after 10 years is where they're going to have the same attendance. Go ahead and write the equation that we used. So for the black one, that was our linear one. This is the equation that we typed into Desmos. And then for venue 2 was an exponential. This is the equation that we typed into Desmos. So you're going to want to write these down so that while you're practicing today, you remember what equations you're going to type into Desmos. So task 4. So instead of looking at venues, now we're going to look at investment accounts. So Brooke and Phoebe both have made an investment of $1,000. Brooke invested with a bond and Phoebe invested with a CD. The tables of the values of the investment are shown. So what we're going to do, we're going to write functions that model each of the investments. So we're going to take a minute to type our data into Desmos. And then we'll figure out which one's linear and which one's exponential. All right. So we've got our linear data. So it looks like, oh, let me undo that. So Brooke's table, this is Brooke's table. It looks like Brooke's table is modeled by a linear function because it's a straight line. And Desmos does tell us what the m and the b values are for the equation. So it says that m is going to be 40, b is going to be 1,000. So the equation that we can write is y equals 40x plus 1,000. So it tells you what m and b are, so you really don't even have to think about how to write the equation. It automatically gives you the numbers. So that means Phoebe's is going to represent exponential. So we'll go back to Desmos and we'll look at the exponential graph. So here's Phoebe's data. It's an exponential curve, and here's the equation that we get for that. So our A is 1,000 and our B is 0.14. So y equals 1,000 times 1.04 to the x power. And we can go ahead and just graph. So my linear one started here at 1,000 and was a straight line. And then our exponential graph started in the same place, but then started to curve. So you need to know the difference between an exponential, which is curved, and a linear, which is a straight line. So we'll make table 1 our linear table. We'll make table 2 our exponential table. So if we go back and look at the examples that we just did, our linear graph was a straight line, which means we're adding the same number. They have a constant rate of change. So let's just say we started out with $1,000 in our savings account. And each month after that, since it's linear, we're going to be adding an additional $100. So the second month would be like this. And then the third month would be like this. We're just going to keep adding that $100. So linear, we add the same number each time. So this table represents a linear function because it has a common difference. So the number that we're adding each time, the common difference of 100. We're adding 100 every month. And the equation of our linear graphs, just like we did in the last two tasks, is y equals mx plus b. So the graph is produced a straight line. All right, so exponential graphs, they curve. They're not going in a straight line. They're not having the same number added each time. Okay, so our exponential functions, let's just say we start at 1,000 again. So the thing about exponential functions is it grows a lot quicker. So instead of adding the same number each time, we're going to be multiplying by the same number each time. So let's just say we're multiplying by 2. So then that would mean that the next value would be 2,000. And then if we multiply that by 2, the next value would be 4,000. And then we keep multiplying by 2, and that gives us the data of our exponential function. So the table represents an exponential function because it has a common ratio, meaning we're multiplying by the same number each time, of 2. So the number that we're multiplying by each time is 2. And just like in the previous activities, the exponential equation that we use is y equals a times b to the x power, and it's more of a curve. It's not a straight line, it's a curve that's increasing or a curve that's decreasing.